Okay, now we're talking reducing loan repayment. So when we look at a reducing interest loan, the repayments themselves are a little complicated to work out. So a bank would normally, or a sort of building society or credit union, would use a computer and a fairly complicated algorithm to work this stuff out. However, we can use a table, so like the one that I've got superimposed over here, in order to work these amounts out. So this table you have access to on the OneNote, so it's come from a textbook. You can normally find these alongside any of these questions. So whenever you see that you need to be starting to look at reducing interest loans and that you're looking at repayment amounts, you will need to find the table. They're fairly simple calculations in themselves. However, you need the table to work these out. All right, so basically what we do is we use that table to work out the minimum monthly, so like our monthly payments on a reducing loan at a particular interest rate. So you can see the interest rates down the side, and across a certain number of years you can see along the top there. So because our reducing interest loans are approximations using the table, what we do is for our final answer, we always round up to the nearest whole number. Again, just because we're making approximations. So if we have a look at this first question, so find the monthly payment needed to repay a loan of $45,000 over 25 years at 9% reducing interest. So the first thing I need to do is look at the monthly payment. Oh, forgot the L. On $1,000 from the table. So to do that, what I do is I'm going to locate the 25-year column down the side, like along the top here, and look down that column. And then I'm going to find 9% down the side. It's got 9%, 25 years. 9%, 25 years, and where they meet, that's the amount. So when I have a look, it's $8.39. So for $1,000, my monthly repayment is $8.39. Now that I know that, all I need to do is work out how much I need to repay on a loan that's more than $1,000. So I need to know how many thousands of dollars. So that would be on my $45,000 loan. So all I do for that is I actually multiply it by 45. How do I know? Because 45,000 divided by 1,000. I need to know how many thousands are in there. And then I'm going to multiply that by the 839. So that's going to be 45 by 839. Now, you won't have to actually show this bit every time, really, because it's a fairly standard amount. You can jump the decimal, whatever it is you need to do. You can just write in square brackets divided by 1,000 to indicate that that's what you've done. But you can just then multiply by 45. So it's this is the repayment on 1,000. So if I have 45 lots of 1,000, I just multiply my repayment by 45 to end up with 377.55. So remembering that you need to round up, okay, because wait for the bell. So because you are dealing with an approximation, as I said before, you need to round up. So $377.55, always round up, $378, the nearest whole number. Okay, so easy enough? Okay. The only other one that you will come across is this second example. So if you have a little read, what you'll notice is the difference between these two questions is that the percentage rate given in this one has a decimal. So it's not just a whole number decimal, which is what these tables are based on. So you can see in these tables, they're all whole number decimals, 5%, 6%, 7%, 8%. So what you have to do is interpolate to figure out the amount in between, to find that in between value. So there's a couple of extra steps when you have a question with a decimal. So first of all, we're going to have a look at our monthly payments. So on 1,000. Now what I'm going to do, sorry, I actually might put the 16% here. So we're going to have at 16%, and we're going to find from the table the repayment on $1,000 at 15%. So because we're between 15 and 16, 15.7 is between 15 and 16%, we need to find both. So my 16% is $13.91. My 15% is $13.17. So if I look at that, the difference is going to be $13.91 minus $13.17, and that gives me a difference of 74 cents. Now, what I do there is, in order to find that 0.7%, I'm going to multiply this difference by 0.7, and then I'll add it on to the 15% amount. So if this is how much I have to pay at 15%, I know it's going to be less than $13.91 because that's 16%, but it is going to be a little closer. So if I have a look then, so my monthly payment on 1,000 is going to be, so this is not looking at either of these, I'm going to have my $13.17 amount for 15, that's what I need to start with, plus I'm going to add on my 0.7 times my 0.74, yeah? So this 0.74, remember, I need, because it's 15.7, I need 0.7 of these, the difference between them. So, of course, I do this one first because BIMDAS tells me always do my brackets and my multiply first, and then I add on my 13.17. What I basically end up with, again, sorry, because I should be using the correct equals, I have around about 13.69. So we can see it's not more than the 16%, but it is more than the 15%. Seems to be a kind of check for reasonableness. That seems a reasonable amount. So then my payment on 32,000 is going to be 32 lots of, because remember up here, all we were doing, once we found out, so this is the amount on $1,000, just like we did up here, we just had to do a little bit extra to find that amount. So $13.69 for $1,000. I've got 32 lots of $1,000. So I'm just going to multiply that. So I can just put over here that I divided by 1,000 to get the 32. And what I end up with is 438.08. Now remembering when I write my concluding statement, I need to round up. So my monthly repayments on 32,000 will be, okay, 438.08. Even though it's only a tiny little bit, I round up, so that'll be $439. Okay, so that is reducing loan repayments. So when we're looking at reducing interest loans, we're looking at the repayments needed. We need to have that table in order to work out the amount that's going to be paid back each month on that compounding loan. And then we just have those extra steps when we're dealing with a percentage that has a decimal. So make sure you practice some of the questions in the OneNote. Give it your best go.